we're going to talk about recursive types and functions. Okay, cool. So let's see, what are recursive types? Well, until now we've seen like only non-recursive types. So let me give you an example of a type that needs to be recursive. So are you familiar with the lists from, like, maybe you've done lists in like for C or C++ back in like 10th grade or whatever? Like I think we usually call them linked lists here.
Okay.
But anyway,
Well,
if you don't remember, that's fine.
yeah, no.
Okay, cool. So so think about this. Like, we kind of want to be able to hold like more than like an arbitrary number of integers, let's say, right? So right now we cannot create a data type that holds like maybe 1 or 2 or 3 or 10 or 100 numbers, right? We only know to do like numbers equals, well, right, and then this can hold 4 numbers, right? But what if I want to hold like 6 or 2 or whatever, right? So we don't know how to do that right now.
So can I compare it to what I already know? Like, is this an array?
Sort of, but like usually arrays are kind of like you can grab them by index,
Mm-hmm.
right? Whereas lists are not indexable.
Okay.
You just go, but yeah, the concept is similar. It's a container,
Okay.
but
No. Yeah.
okay. Oops, I didn't mean to.
Did I do that or?
No, it's fine. I think I did.
Okay.
Okay, so instead, what can I do? So we can do data. Let's say int list, like a list for integers. Like, let's just list int, right? And then how do we do this? Well, let's say that we want to allow lists to be empty, right? Do you agree? Right? It's fine, right? Lists can be empty. So you can do empty here, right? An empty constructor, which means a list is empty, right? And then we can say like, okay, we want to like make list. Let's say the other constructor is, right, where we have an integer as a value. Okay, and then we also have a list int, which is the exact same thing we're defining.
Yeah.
Right, so let's look at a few examples before I explain the idea here, right? So let's say, okay, the empty list, what's the empty list? If we enter that, well, empty list equals empty, and that's it, right?
Yeah.
And that's easy, right? One element list, oops, is also a list int, right? They're all the same type. So how do we write this? Well, we do make list, right? We put the value 1, for example.
Yeah, and then you list it, right?
Well, list int is a type, right? It's not a value. So if I want to create a list int, what can I do? Well, I can either do another make list, or I could do empty. Right? So here I need to do empty.
Okay.
Right? So you can think about empty sort of like a terminator for lists. Yeah. Right? Yeah. So if we want to do 2 elements, right, we can do 2 elements equals mk list 1, right, mk list 2, and then empty. Does that make sense?
Okay. Yeah. It
okay,
does.
Cool. So this is how they look, right? So you can think about them kind of like what should I call it? Like kind of like an onion, right, where you add more and more layers every time.
Yeah.
Right. Okay. Yeah. Cool. So the idea here again. So remember, this is like an empty constructor, and this is a constructor which takes the thing that we want to hold, like the int that we're holding there, and then it recursively takes the same type here. But like list int isn't something that can live here. It can only live here at the type level, right? It's not something that we could use at the value level. At the value level, we can only use empty and mk list, right? As far as list ints goes. Okay, cool. So let's see, what kind of functions can we define over lists, right? Because like we have a few examples of writing lists here, right? Like a few lists. What kind of functions would you think that are possible over lists? And again, you can think about arrays, and they should be kind of similar.
Yeah. Oh. Like real life examples, or of what I did as a homework?
No, so for example, like let me give you a few examples, right? So for example, we could count how many elements are in a list, right? That sounds reasonable. Like that's a very often found function, right? So we can say count, and how do you think this function would look like? What would be its signature? if you were to guess.
Okay. Okay, but give me 1 second to think about it, because, well, it would return an int.
Yep.
And like list int.
Yep. Yeah, exactly, right? So we take a list int, and then we want to return the number of elements, right?
Okay. Yeah.
Let me write this down for you, because I don't want to put you on the spot and give you.
Do I have to use show as? No, it's not show. No,
you
that's
don't even need
concatenation.
show.
No,
So
yeah.
let's look at for a second, right? So,
Yeah.
so usually when we have a what's this? This is a sum type, right? I mean, it's a recursive type, but it's also a sum type, right? So, but even if it were, right, whenever we have our own data, what do we do, right? What do I say we do? Like, what's the only thing we can do? Oh, well, this is called pattern matching. I know you kind of call it creating, but it's pattern matching, right?
Yeah. Okay.
Right, so, okay. How many elements does an empty list have?
Empty list. 1.
Well, why is it 1? Isn't it 0? Do you have any integers?
No, it's 0.
Right? Like, you don't have any integers, right? So it's 0.
Yeah.
Okay, so if we were to count so what's the other constructor? Well, it's an MK list, right?
Yeah.
Which has some value here, which we don't care. We just need to count it. We don't care what it is, right? It can be 100, it can be 42, it doesn't matter, right? And then we have a rest of the list, right? Like, look here, right? If we are here, it's MK list 1 and then some other list here.
Yeah.
Or it could be empty, but empty is also a list, right?
Yeah.
Okay, and then if it's empty, it doesn't reach here, right? It's just here.
Yeah.
Okay, cool. So, okay, let's see. So if this is an MK list and the rest, this is how this works. And I won't let you guess because this is maybe a bit tricky sometimes, right? So let me explain. So you have one element. You know for sure that you have one element, right? This one, right? And then we add count over rest. So this is a recursive function.
Okay.
Right? So what does this mean? Well, I don't know how many elements are in rest.
Yeah.
Right? But we already know how to count elements in a list. Well, we just use count.
Yeah.
So it's kind of like you build a function by using itself, right? Calling itself recursively.
Okay. So basically, I eliminate the first integer. And then I start over from the second element when I recount the
and that's a
function. Yeah,
that's a very good intuition, illuminating, right? Because this is exactly what the idea is, right? So when you do this, when you pattern match and then remove the head, you could call it.
Yeah.
We're both Romanian. Can you tell from the accent, or? I'm from Bulgaria. Okay, cool. So let's see. When you remove the head here, right? When you cut off the head, you'll necessarily have something that is smaller, right? Like, even if you have 1,000,000 elements in your list, when you remove one element, like kind of like this, the rest will have 1,000,000 minus one element, right?
Yeah.
This time. But then the next time you call count, it will be 1 minus and 1 minus and 1 minus and so on, right? So this, like, you can kind of think of like you're removing things from the list you're taking and adding numbers for each one, right? Adding 1 for each thing that you removed.
Yeah.
And you go on until you reach empty, and you'll eventually reach empty. There's no way you don't reach empty, right?
Yeah.
At some point you reach empty, and then that's 0, right? So like this will end up being like 1 plus 1 plus 1 plus 0, right? Always. That will always be the case, right? Of course, it could be just 0, right? Or just 1 plus 0 or whatever, right? But if it's a longer list, then you get something like this, right?
Yeah.
Does it make sense?
Yeah.
Okay. So, I think we need to import prelude. Because we don't know what int and plus is without prelude. Okay, cool. So this is how we define count. Let's see, what other things can we do over a list? I mean, counting is the easiest thing we can do, I guess. So
okay, well, there's also the sum product of it.
Okay, right. You're right, because it's an integer list. So so we can do a sum. Okay, sure.
But it's kind of the same, isn't it? Like...
okay, try it.
Okay, so it's the exact same thing.
And I think we're back.
Yeah. Now it's fine.
Okay, cool. Yeah, I'm not sure. I think I need to update Streamlabs. It's been happening, or maybe downgrade. I don't even know, but it's been happening like every stream, every like after an hour or two of streaming, it just gets disconnected. It doesn't even notify me or anything. It just the stream dies, and then I just restart Streamlabs and it works. So no, we're actually not co-workers. I like Andrew is a friend of a friend, and I was just looking for some like somebody who wants to learn, and he said that he wants to learn. He didn't know FP before, so and he seemed eager, so that made him a good candidate, right? So yeah, that's the story. Cool. So do you want to update to change this function yourself? So I just copied the one from above, and then I just removed some with product. Okay, and there's one more change. Yep, perfect.
Yeah.
Yep, that's exactly correct.
Okay, so this one I'm actually impressed with myself because this one actually makes the most sense out of everything we've done so far. This one is
cool.
Okay.
Cool. I mean, I'm happy that it does. Okay. Well, hopefully that's going to be a trend now, right? Because as you learn more things, then it should kind of start making more and more sense.
Yeah.
Okay, so yeah, you had a good idea. Sum and product are definitely cool functions to write here.
Okay. So what if we do sum ifs? Only make a sum if all the numbers are even or odd? Is that too complicated?
Maybe that's a homework thing. No, it's not too complicated. Maybe that's a homework thing. Okay, so let's see. Let's say we want to. How do I explain this? Okay, let's. Okay, I know how to do this. Okay, so let's say that we want to find a number in a list, right? Let's see if a list has a number or not. So how do we do that? How do you think the signatures look? So let's say we call it find, maybe, right?
Okay.
So how would the signatures look like?
Well, I still have to go for a list int.
Yep, that's the input, right? Because that's what we're operating over.
Yeah, that's what I'm looking in. And, well, do I have to find the number if the number is in the list, or do I have to count how many times it's found?
Just if it exists or not.
Okay, so it gives us a... Oh, no, it should give me a boolean, actually, because if it...
Okay, but then there's one problem. What are, which number are we looking for?
Okay, so go for int then.
But then also boolean, right? So this is the list. Okay, so this is what you're looking for, and this is the result. Yep, exactly.
Yeah. Okay. That makes a lot of sense.
So do you want me to write this, and then you can write the next one, or do you want to have a try on this?
I think it would take me like 2 minutes to write. I think it would be faster if you would write it. It would make more sense for me.
So let's do this. So we have fine, right? So and then let me do this. Let me reorder this, right? And you'll see. It's not that important, but it will make the function a bit better. So we want to find the value x, right? Some value x.
Yeah.
And then if we have empty, then we know we have not found it, so it's false.
Yeah.
Right? Okay. And then we can, if we're trying to find x in some list where we have y and rest, right? What can we do? Well, we have an if here, right? So if x equals to y, right? Then we know it's true and we're done.
Yeah.
So what do you think would happen? Like, you don't have to write the code, but like just think out loud. What do you think we should do here, right? So let's say we're looking for the value 2 in this list, right? So we are here, 2 isn't equal to 1. So what should we do if we have not found it here?
Yeah, we should just keep looking in the rest of the list.
Okay, so it's fine.
But I have,
X and rest. That's everything we need to do.
Mm-hmm. Yeah.
Right, so it's, wait, I think we have some problems here. Let me see. Did I, okay, it's capital K here instead of, it should be like small k. Okay, that's fine. That was the only problem. Okay, cool, right? So you can see kind of like it's kind of a trend here, right? When you're working with a recursive type, right? Yeah. Like list, most of the interesting functions you'll write will also be recursive.
Mm-hmm.
Does that make sense?
Yeah.
But because also the type is not only recursive, but also a sum type, right?
Yes.
Then also most of the functions you do will do pattern match kind of like this, where we handle both cases. Right?
Yeah.
So it's kind of an idea that, okay, when you like the type of data you have, right, will kind of force your functions to have a certain shape, right?
Yeah.
Which is pretty interesting, right?
Yeah.
So you kind of know when you write a data type, like kind of how the functions would look like, right? So, or at least after you get some intuition or you get used to this, you kind of like, oh, okay, so this data has this sort of type, so I need to, like in order to do something interesting with it, I need to do a recursive function and that matches like that. It looks on the cases, right?
Yeah.
Okay, cool. So let's see, what other functions can we write here? Well, we could, for example, we could count how many items, like we could say, instead of find, which finds the first item, right?
Yeah.
We could see how many times we find X inside the list.
Okay.
Right, so if we have a list that has 2, like 3 times, we should return 3, right? And if it finds it 0 times, then it's 0, right? It's instead of a boolean, we do a number, right? So let's say find count, I guess.
Yeah.
And how would this look like?
Well, I still need to give it an int so that I know which. Where am I typing? I think
I'm not sure.
Okay. Well,
let's see if you type something somewhere. No, it doesn't look like it.
So.
Okay.
Okay. And then this one goes into the. So basically,
it's good
I
so
give
far.
it this. I look into this, and it returns an int.
Yep. Perfect.
Because it tells me how many times it finds it. So now find count.
Okay.
Where I know that. Wait. So if like this.
Okay. So what's the result here?
I would just put this because it doesn't matter, but.
Well, no, you have to return something, right? It's like you can never write just an underscore.
0?
Yep, right. So like how many times does 3 exist in an empty list? Well, 0 times, right? Any number exists 0 times in an empty list. Okay.
Yeah. Oh, I have to. So I'm not used to functional programming. I know that I would use as an incrementer, and every time I would find the number, I would just increment it by 1. But here, well, I have to find the x, then create this, and it's x, rest.
Yep. Well, no, because notice the find, right? You can't use the same binding here, like x and x, right? You have to use x and y or something.
Yeah. Sorry.
Cool.
Yeah.
Okay. So what do we do now?
I still have to do if x is equal to y.
Yep. Sure.
Then and well, I would do something like +1 somewhere.
Okay, so let's think about it for a second, right? So +1 is a great intuition. That's perfect so far. So okay, let's see. We have found 1x in the list, right?
Yeah.
But then there might be some other
maybe
in rest, right?
Yeah. So should I just go empty? No.
So let's say this. So we know that we have at least one element there, right?
Yeah.
In there.
Yeah.
Okay, but then we could have like more elements in rest, right? So what's a function that given an int to look for and the list gives us how many ints are there?
The count function. Oh, okay. So
well, the count will just count how many are in rest in total, but it will not count only the ones that have x, that are equal to x.
Okay. Yeah, no, I need some help here because I would just do this count. I don't know, like my brain is just telling me to write this. Yes.
Right. I understand that. Okay, cool. So let's see. So it's usually like, okay, 1 plus was correct instead of +1, right? 1 plus is correct. But then what do we add? Add or we add find count x and rest.
Okay.
It's kind of exactly like this, except we need to add 1 to the result, right?
Yeah, well, it makes so much sense once you write it down. Yeah.
And then what do you think is for else?
Otherwise, I just find count.
Yep.
X in the rest of the function.
Exactly. That's exactly correct. I'm not sure. Let's see if this compiles. Okay, so I usually do this, right? When I have an if, I usually make the if on more on the left than the rest. But I guess that also compiles, so it's fine. Okay. So do you understand why this is so like now? Like why this works?
Yeah. Because it gives me the result of the. So if it finds it again, it's gonna be another one plus the other one.
Yep.
Yeah.
So basically, what does this say? Okay, so we use 0 as the empty thing, right? And then we use +1 every time we find X, and nothing every time we not find it. We don't find it, right? So we just do +1 every time we find it.
Yeah.
Okay, cool. Okay. So now I think I want to show you a weird function.
Okay.
Let me think if we can do something else before. Yeah, let's do something else before that. So let's say that we want to write a function, right? That, let me think. Okay, let's start with the simplest thing. So let's say we have a list, right?
Yeah.
And we want to add a number that we pass as a parameter at the beginning of the list.
Okay.
Right, so let's say
expand the list or
sorry?
Or what? Expand the list? Or
yeah, so this is usually called prepend.
Yeah.
Where if you have a number and a list int, you give me a new list int, right? So let's say if we were to type things to write things like this, so this is the list with 0, 1, and 2 as the elements, right? So if we do prepend of okay, let's say we have this, right?
Okay.
So if we want to prepend 0 to 1 and 2, the result is 0, 1, and 2. Oops. 0, 1, and 2, right?
Yeah.
Okay, so do you think you can write this? Or do you want me to write it?
Prepend. Well, I have to.
It's a bit of a trick question because it's very, very simple.
Okay.
But I can write it if you don't get it initially.
Okay. Can I have 10 seconds to think about it?
Can have as much as you like.
Okay. Okay, so I'm not gonna, but it's no, I just lost my idea.
Okay, so first thing, as I said, you can never write list int only here, not here, right? So here it's it's either empty or make list, right? So this the most simple way to implement it is kind of like this, right? Without thinking too much, you could do mk list x and empty here, and then we have prepend x with mk list of some y and then rest. You could say the result is mk list x mk list y rest. Does that make sense?
Okay, so wait, I make the list x and then I end it. I get the empty.
Right, because initially I have an empty list and then I have a list of one element here, right? And then if I have whatever other list here, like a big list, then I just make a new list where x is the first element, and then this is whatever it was before.
Yeah, got it.
But then this thing you can also rewrite as this. X and y, rest equals to... Because let's think about it, right? If here I take empty and I put empty on the right-hand side of make list, right? And here I take this thing and I put it on the right-hand side of make list. So it's kind of like, okay, we don't even care what it is. It's just make list. Right?
Okay.
So prepending or putting an element to the beginning of the list is literally just our list constructor. That's what it does, right? That's how it works.
Okay. Yeah.
Okay, so what if we want to do the opposite, the append, right? So it looks the same.
Yeah. Do I just reverse the entire thing?
But I want not just not really reversing. So append 0, it keeps everything in position.
1 and 2, yeah.
But then it puts 0 at the end, right?
Yeah.
Do you want me to write this? Because this is a bit trickier.
Okay. Yeah, go ahead.
So let me try to explain as I do it, right? So we want to append x, right? So in this case, we kind of have to do a case-by-case analysis. We can't do it like cheating like here, right?
Okay.
So, okay, if we have an empty list, what do you think happens?
I get make list, right? So I have to make the list where it's the rest and then the x.
Well, there's no rest, right? Because we only have x and empty.
So
like
and so it's x and empty.
Yep, right. Because like, okay, I want to add an element to the end of the empty list. Well, I mean, there's only one. There's only one element, so it doesn't make sense, right? But I mean, it's fine to have this case, right? Okay, cool. So then, what happens if we want to add x on a list which already has an element and some? Oh, sorry, y and rest.
Y. Yeah.
Well, we have to start with a list, right? Because like, okay, what can I do here? Well, I could do empty, but that's wrong because we just lost our list, right?
Yeah, but can I? Oh, sorry. Is it like make list where it's rest and x? Like
well,
this?
no, because then first of all you lost y.
Okay.
Right? You have a y which disappears when you do this. Okay. And then rest is a list, and then you have to put. Oh, don't worry, Genesis. I just I think I would have responded to it, but I was like in the middle of explaining something. I am not offended. Don't worry about it. So rest is a different type here, right? Rest is a list. Yeah. So the first argument here needs to be an int, not a list.
Should be an int. Okay. So it should be y. Or
yeah, that's good.
Okay. And
well, so if you do this, then you just don't do anything,
I just
do
the exact same thing. Yeah.
You just throw an x, and then you just like this is it won't work. It's a bit tricky. So let me explain how you think about this, right? So, okay, what we want to do is we want to keep the list as is, right? So this is the list. So we want to keep the list as is.
Yeah.
Right. So if we're at 1, we need to move forward, and if we're at 2, we need to move forward, and we need to do that until we find the empty. Where only in the empty case do we do something interesting, right?
Okay.
And this is the empty case, right? When we reach the end of the list basically, right? Because this is kind of so whenever you find, like you see this empty case, this doesn't only apply to empty lists. It also applies to the end of the list, right? Because for example, if you multiply the list 1, 2, and 3, right? You do multiply a product here, right? What will this be? Well, it will be 1 times 2 times 3 and then times 1 again, because this is empty actually, right? Because this is the same as product. Make list of 1, make list of 2, make list of 3, and then empty. Right, so you always have an empty, regardless of anything, right? So this case is not only for like just product empty, which is just 1.
Yeah.
Right, it's also for all the other lists, because any list contains an empty, right, at the end.
Yeah.
Right, so in this case, we need to go until we find empty, and then in the empty, you actually do the interesting thing. And then what we need to do here is, so we have, what do we know here? Well, we know that we have not reached the empty yet, right? We know we still have elements. But then rest is another list, and rest could be empty. It could be an MK list, right? It could be longer, but it could be empty. So what we need to do is we need to do append x rest. Right, so we're kind of moving the recursive call inside here, right?
Yeah.
So what happens when we do this? Well, this is kind of like... so let's say you have the example there. So we have append 0 and then 1 and 2, right?
Yeah. And now we just go through the list and we get the one out of this equation, basically.
So let me type like this: mk lists 1, mk list 2,
and then we have an empty,
right? Okay.
Yeah. Yeah.
So the first time we enter this function, we reach this thing, right? So what's the result of this? Well, the result is mk list of 1, then append 0, mk list to empty. Does that make sense?
Yeah.
right? And then what's the result of this? Well, it's mk list 1 and then mk list 2 and then append 0 empty, right?
Yeah, and now it finds the empty.
Like you see how append goes inside, right? Each step, like it's here, then it's here, and then it's mk list 1 and then mk list 2 and then what's append 0 empty? Well, it's mk list x empty, right?
Yeah.
And then we're done, right? Because we don't have append anymore, it's just a list. Right?
Yeah.
Okay. So let's.
I mean, the way you explained it with empty, it just makes it make a lot more sense. Yeah.
Okay. Cool. So now let's think about the different functions. So let's say that we have a. Let's make something a bit tricky that I'm not sure we've done before, but this is a very important function. So this function is called map, but I don't think we can redefine map. So I think let's see if we can do hiding map here, and then we'll call this map. Yeah, again, don't worry. Yeah, okay. Oh, you're trying to say that, but I was talking, right? Okay. So let's say we have a map function. How does this work? Well, if you give me a function from int to int and a list int, I'll give you back the list int. So let me explain how this works, right?
Yeah.
So let's say I want to do map +1. Why is that? Okay, +1 for the list 1 and 2. Right, so what would happen is I would expect the result to be 2 and 3. Does that make sense?
Yeah, okay, so it applies.
So +1 is a function, you remember, right? So +1 is a function that adds 1, right?
Yeah.
Okay, cool. So let's let me write this and then we'll have another example where maybe you can try something. Okay?
Yeah.
So okay, we have a map and then we call the function f, right? From function, right?
Okay.
So if we have empty, what do we do? Well, I mean, we can't do anything, right?
Yeah.
Like we can't apply a function that works over integers on when we don't have an integer, right? It's empty, we get an empty list, right? So if otherwise, if we have a list of some x and then the rest, what do you think happens here?
It applies the f onto the x.
Yep, and then okay, so that's step 1, right? So that's how we get to 2 instead of 1 here, right?
Yeah.
But then what do we do with the rest?
Okay, so wait. Do we just go this?
Almost, but we need to also pass f, right? Because otherwise, like so.
Yeah. I need to apply the function. Yeah.
So that makes sense, right?
Yeah.
And this works. And I think we need to do capital L here, and then it will also work. It was a small L here, right? And then we didn't save, so we had a type error, but didn't notice it. Right. So. And then again, like any function that we're writing, and this is why this is pretty like why I love functional programming, and why maybe if you recall the lambda calculus example, this is literally the same thing as lambda calculus, but we're doing like an easier syntax for evaluation rather than using beta reduction and all of that, right? But it's kind of the same idea here, right? So let's try to evaluate this using our implementation, right? In our like here, right? So. When we have this, we're actually saying what? We're saying map over +1 over mk list 1, mk list 2, empty, right? So what's the result here? Well, it's mk. So we're looking here, right? Mk list, right, in this place, right? So it's mk list of what? Fx, right? So it's 1 + 1, right? And then it's map
2 and empty because it didn't apply to 2 yet.
Yep.
Yeah.
And then let's do both at the same time, right? So it's 2 here, right? And then it's what's map fmk list to empty? It's
mk list 3 and
okay, sure. It's
2 + 1. Yeah. Okay.
Yeah. And then
and now it's mk list. It's actually map f to
on
the empty.
Right. Exactly. And then it's mk list 2, mk list 3, and then map f empty is just empty, right? And that's it. Right? Makes sense?
Yeah.
Okay, cool. Okay, so let me hit you with a hard problem, and we'll see how...
Okay.
I think this already exists. Well, apparently it's not here. Okay, cool, so we can do this. So this is hard. So let me explain how it works before, right? Okay. So you have a good example. So let's say I want to do fold R using plus. Okay. Right? Why do I just say plus? Because this takes two integers, right? So it's a plus b rather than just plus one, right?
Okay.
Of plus, and I give you 0 as this int, right?
Okay.
And if I give you empty, I expect you to give me back empty. I expect to give me back 0. Okay?
Yeah.
Oh, sorry. My bad here. This needs to be an int. Okay, and then if I do folder of plus over with 0 over some list, right? I expect you to do this sort of thing. So okay, so let's do this. Over this is 0, right? And if I have 1, 2, and 3, for example, I want the result to be 1 plus 2 plus 3 plus 0. Why plus? Because I've given you the plus operator, right? So let me give you a different example. I want the same function. If I pass you multiplication and 1, I want this to be 1, and I want this to be 1 times 2 times 3 times 1, because I've given you 1 here, right? So this is this one. So maybe this is not the best. Let's do 2, 3, and 4 instead. Oops. And then 2, 3, and 4 here. And then also 2, 3, and 4 here, just to be sure that we're not... right?
Yeah.
Okay, cool. So let's see. Do you want me to try it, or do you want to just try writing a few lines, and then when you get stuck, I'll help?
Okay, so I can start.
Okay.
Where so we go for the plus at the moment. So
no, just type f there as a function, right? It's some function f. Fold dr. Okay, f, and then you get some integer.
Do I go for the empty?
No, don't forget you still have this int that you need to take. So it's f, x, and then empty.
Yeah.
Right, because it's plus 0 and then the list.
And now it's just empty.
Are you sure it's empty?
Look at the make list of empty.
Are you sure it's make list? Look what we're returning. So we're returning int.
0.
Why 0? Because if I pass you multiplication, you need to give me 1.
Ooh. Okay. Help.
Well, so f is this thing, but x is an int, and you need to return an int. So isn't it just x? Don't you just need to return
x? Okay. Yeah.
But without MK list, right? It's just x. It's just an int, right? Okay. So let's try writing the other case. Yeah.
Folder f.
At x again, and then the only difference is the empty, right? We need to do MK list. Okay, and then we have like some y, right?
Yeah.
And then
the rest of the...
and then some rest.
Yeah.
Okay.
And then it's equals to.
Okay, so first of all, like remember the functions above. If we return a list, then we need to do MK list or empty, right? But if we return some, let's look here, a number, then we don't do that, right? We just do some operation, right? Return some numbers or whatever, right?
Okay.
So we don't do MK list here at the beginning, right? Obviously, because we're not creating a list, right?
Okay. Yeah.
So okay, the way you think about this sort of thing is okay. So what can I do with the things that I have, right? I have an x, and a y, and the rest, right?
Yeah.
So maybe it's useful if we just let's write it here in a different kind of comment, just because it's not related to that previous comment, right? So what type is f? Do you know what type is f?
It's wait. It's an exponential type, because
yeah, but like it's literally int to int to int, right?
yeah,
but yeah, it's an exponential. And what type is x?
it's an integer.
Yep, just an integer. What type is y?
Y is an integer as well.
Yep, and what type
And
is
the rest is a list.
Yep, a list int, right? Exactly.
Yeah.
Okay, so kind of think of it like puzzles, right? Like Legos or whatever, right? Okay, so I have these things. How can I combine them? Like, how can I build a pretty little castle with these things?
So first I have to, I have the foundation where I have these three things. So, nah, they're actually four. Okay, so I actually have no idea how to do this, to be honest.
Okay, so the way you do it, okay, so maybe we could look here, right? So when you're here, right?
Yeah.
You kind of have to do 2, right? What's
Yeah.
2? It's this element, like the first element from the lists. So what is 2 from this thing, right? So f is plus, right?
Yeah.
X is what?
X is y. X is the 0.
Yeah, exactly, right? So f is plus, x is 0, and then in the first iteration, y is what?
Y is 2.
Yep, and then rest is 3 and 4, right? A list 3 and 4, right? So we want to do what? 2 plus, right?
Yeah.
So how do we do that?
Well, it's
so we
I apply the function.
Yeah.
No.
Yes.
Yeah, and then I apply the y because it's the 2.
And then we need to do plus 3, but where is 3 in our case?
Well, it's make list.
Well, no, it's not make list.
No.
It's inside rest, right? It's already inside rest.
Yeah.
Because rest we said is 3, 4.
So do I just write rest?
Well, not really, because rest is list int, but we need an int here, right? So we set fy, right? And fy is like we've kind of neutralized the first argument, right? So then
I apply the function to the rest again, right?
I think that sounds right, but type it out so I can see. Well, not quite. Because again, like you can't say fres because this is a list int and you cannot pass a list int to f because f wants ints. So this is almost right. You have the right sort of idea, but what you actually do is you do recursive. So you do fold r, f, x, and then rest.
Oh, okay.
It's a bit of a mind bender. So okay, let me preface this by saying that fold r and fold l and whatever, you should just probably call this fold, right? Because it doesn't even matter. I don't care whether it's right or left at this point. I'm not even sure I wrote the right instance for fold r there. Okay, so let's just call it fold because I don't really care at this point. So what this basically does is it's kind of so you're kind of like, okay, I have 2 plus, but how do I get to the rest? Well, I just do the rest, right? So let's try to unwrap it like we did with the other ones. Maybe that will be easier to understand, right?
Yeah.
So let's keep this, but let's maybe put this on top because this is how we used to implement it, like what we thought about. And let's do like the first example, like this one, right? Let's where is it? Let's grab this example and then throw it here and then try to see how it works out, right? And then let me delete this, right? So this actually is fold of plus 0 over mklist2, mklist3, mklist4, and empty, right?
Yeah.
Okay, so after the first step, what do we have? Well, we have plus and 2, right?
Yeah.
And then we have this thing, right? Fold plus 0 and then mklist and then with parentheses here 3. Okay, you following so far?
Yeah.
Okay, so you have plus 2 here. Well, let me keep it like this, right? Plus 2, right? Well, actually, okay, let's rewrite this as 2 plus because that is the same thing, right?
Yeah.
Okay, so we have 2 plus, right? And then what's fold 0 blah blah blah? Well, it's 3 plus, right?
Yeah.
And then what's
And then we
the rest?
apply. Yeah, we apply again the fold plus 0, and then it's make list of 4. Yeah.
Right, and it's this. And then what's this? Well, it's 2 plus 3 plus. So what's the result of this? Well, it's 4 plus, right?
Yeah.
And then it's fold plus 0 and then empty. Correct?
Mm.
And then let me do this thing. Okay, so what's 4 plus 0 and empty?
I mean,
So it's
fold, but yeah, but this time it's just.
So so this matches with this constructor, right?
Yeah.
So it's x.
So
What's x? It's 0.
So it's 4, right?
What do you mean?
Oh, x is 0. Yeah.
X is 0.
Sorry,
right?
sorry.
So it's
Yeah.
plus 0.
Mm-hmm.
I think that's correct, right? So it's 2 plus 3 plus 4 plus 0.
Yeah.
Okay, and it's kind of this. It's the same here, right? Except you replace multiplication plus with multiplication and replace 0 with 1 everywhere, right? And that's it. It's the same thing.
Yeah.
So let me give you another thing here that you can think about. So let's say that we have make list 2 and then make list 3 and then make list 4 empty, right?
Yeah.
So instead of writing it like so, we could just write it. So let's say that we say that this operator, which we call like this what's this called? Colon. Okay, this colon operator. Let's say mk list is this, right? So like just notation, right? Instead of mk list, let's write colon, right? So you can say 2, 3, 4 empty. You okay with this? That these two are the same thing?
It just changes. It's a pseudo. It's an alias, right?
Yeah, it's an operator, right? So instead of saying mk list 2, mk list 3, mk list 4 empty, you could just say 2, 3, 4 empty, right?
Yeah.
It's just a different notation, right? You could say that, okay, instead of saying 2, 3, 4, and that's it, we'll just write it like so, right?
Mm-hmm.
So what does fold do? Well, you can think of fold as replacing this
with the plus.
With the operator, right? So it's 2f, 3f, 4f empty, but it also replaces, so fold replaces plus with f, let's call it, right? And empty with x, right?
Mm-hmm.
And x here. And this is everything, all that fold does, right?
Yeah.
So let's look at a few cool things we could do with fold, right? So for example, we could say, so let's think, how can I even, let's see if we can play with the REPL. But I've not shown you this so far, so let's see if that's a thing that we can do. So if I import part 3 and look at the type of fold, yeah, okay. So let me write it down here somewhere, just so you can also do that the same. So project run spago REPL. Then you can do what did I do? Import file name, right?
Yeah.
Well,
and
module name.
Yeah, and then the type. Yeah.
Types with the like colon T name, right? And you get the result. But you can also run things, right? So we could say, for example, fold. Well, we also need to import. I think we already have prelude, right? It looks like it has it by default. So we could say fold plus 0 and then mk list 1, mk list 2. I think I did a capital K here.
Yeah.
And then empty. And then the result is 3, right?
Oh, it works. Okay.
So you can try things out here and then run them easily, right? So you can play with it, right? So again, we could, for example, do multiplication and then 1, right? And then it's 1 times 2. Okay, so then we can do one more thing. So I want to show you a few cool things that you could do with the fold, right?
Okay.
So what do you think happens if you do mk lists and then empty here? Let's make it. I think I need more of this. Oops, no. Oh wait, it doesn't matter. It doesn't work because this is a list for ends. Okay, never mind. I can't show you this. I'll show you this later.
Okay.
Okay, never mind. So what kind of other things can we do with this? Yeah, I think we can only do numeric things, right? Because this won't work. Oh, okay. One cool thing. So what if we do... So give me 1 second. I need to think about this for a second. So which one is... so it's... Yeah, I think it's y that we need. So we need to return y plus 1 here. And we need to start at 0, I think. Yeah, there we go. So this, like, if you pass this function and 0 to fold, you get the count of the list, like how many elements a list has.
Okay.
Let me show you that that's correct, and then we can maybe think about why that's the case. Right, so it was 3 there, and it's 4 now, and so on, right? So let me try to explain why. So, well, I mean, okay, before anything else, like we now know that we can rewrite, where is it? Sum and product using fold, right? We've already seen that. Yeah. It's obvious, right? So sum and fold are just fold is just a more generic version of sum and product, right?
Yeah.
So maybe let me write this here just so you can get used to some of the syntax. So maybe we can say sum prime, which is a different version of implementing sum, right? Yeah. Is list int to int, and then sum prime is fold of plus, let's say for some list L, right? Plus 0 and L, right?
Yeah.
Does this make sense?
Yeah.
And then product is for L is fold, multiplication 1 and L, right?
Yeah.
And then these two work exactly like the regular sum and product, but it's we just needed to write fold instead of writing a specific function for everything, right?
Yeah.
Okay, so let's see, what other things did we write? We wrote count, right? So how can we do a count using fold, right?
Okay.
So how do you think about this sort of thing? Well, let's say, so we have count, which is list int to int, right? That's the same sort of thing here, right? So, well, we need to do count prime just so it's a different number, right? So we can do fold. Then let's say a function f, right? And then some number x and then L, right? Let's do this. So now let's think about what f and x need to be, right? We can do here something like f is a function from int to int to int, right? Are you following so far? Okay, and then let's say f prime here, just because it's different. Like it's just a new name right here. Okay, and then we have an x and an y here, and then we need to return some value, right?
Yeah.
Okay, so let's see. So we are passing this value here, and what are we doing? We're calling that function, and we give it y, right? Which is the...
I don't know if you hear me, but I think you dropped.
Can
you hear me?
Yeah, I can hear you. Can you still hear me? Is the stream still on? It looks still on to me. Let me grab him. Can you hear me now?
Yeah.
Okay, I was hearing you. You were just not hearing me. I'm not sure why.
I couldn't hear you.
Okay, cool. Doesn't matter. It's fine. So what's the last thing you heard?
The last thing I heard was when you told me that it gives a value. So it's f prime, x, y, and it...
Okay, and it returns a value. Okay, cool.
Yeah.
Right, so I need to replace this question mark with something else here, right? So let's see. We have... So how are we calling this f? Well, the first argument we're passing is y, right?
Yeah.
Which is the actual elements of the list. correct? So here the Y position represents the actual elements of the list. Well, the X position, sorry. Let's do this. Right, because like here we have Y, right? So let's talk about the same Y here, right? So it's not confusing. So the first argument is the like each element of the list. And then the second argument is the kind of the result of the fold, right?
Yeah.
Okay, so this will be 3 the first time, and then 2, and then 1, or whatever in our example here, right? Or 2, 3, and 4, right? And then the last thing that will be, so on the right hand side we'll have this thing, right? Like the 0 or whatever. So the way I think about it is like this. Okay, so if I want to count the elements, right?
Yes.
I want to start like, what's X? Well, X, this X, like the initial value.
Yeah.
Let's call it X prime as well, just so it's maybe slightly less confusing, which is an ant. Well, like an empty list has 0 elements, right?
Yeah.
So X needs to be 0.
Yeah.
Right, that's our base case. Okay, so what do we want to do here? Well, when we add these things, we want to say that, okay, Y is the element in the list. So we need to ignore that, right? Because if we have like the number 3 in the list, we don't need to add 3 to our count, right? So we need to ignore this. Right?
Yeah. So far,
this
so
thing.
good.
Okay. So what do we do when we have one element in the list? Well, we do X plus 1.
Yeah. Okay.
And then we do X plus 1 every time we have an element in the list, and then when we reach empty, it's 0. Right? So that's it. That's how we implement count using fold. Right, so how does that work? Well, you can think of it kind of like this, right? So you have, where did we write that thing? Right, it's here, right? So it's 2, F3, F4, Fx, right? So it's, instead of 2F, what's actually 2F? Well, it's plus 1, right?
Yeah.
And then we have plus 1 for 3, and then we have plus 1 for 4, and when we have X, which is 0.
Yeah, it's
right,
just
so
like you said, for every position you get plus 1. Yeah.
So that's how we count. Does it make sense?
Yeah.
Okay, so let's do also this one, count if. Find count, right? Let's try doing a find count using folds. So let's do find count prime, just because it's a different kind of thing. And then, we want to look for the number X. Well, let's call it N here, right? We're looking for the number N in some list L, right? And then we don't even look at that. Okay, so we need to do a fold, obviously, right?
Yeah.
We need to pass some function f prime, right? Some default value X over the list L, right?
Yeah.
So let's just copy this thing from here, and then let's just think for about it for a second. Right, so if we have no elements in the list, how many times did we find N? Well, 0, obviously, right?
Yeah.
So this is fine. The only thing is here, right? So we want to add 1.
Yeah.
But not always, right? Because, like, what can we say about find count? Well, this should always be at least, like, at most equal to this. Does that make sense? Right? Because if we have a list with like 5 ones and we're looking for 1, then the count and the find count should be this. Well, did I name them correctly? Yeah, I think so. Right? So this can be at most equal, but then find count can never be greater or something, right? So, but then this can be smaller, right? It's usually smaller, actually, right? So what do we do? Well, do you have an idea here? Or
I think it should be X prime here.
Okay.
Right?
Just do Y instead of X prime. It's probably easier.
Okay. So this is where the value is the important part to me.
Yep.
And it should be. I'm thinking what to replace in the function so that it actually. It should still be X plus 1 here.
Sometimes, but not always, right? So sometimes it should be X plus 1.
I don't know how I do sometimes.
Well, so let me explain, because this is probably not very intuitive. So when do we want to add... okay, go
So do I just put the if?
Yes, you start with an if. That's correct.
So if...
So what's the condition?
Y equals...
To what?
Wait. Y equals to... X prime?
No, because X prime is always 0.
And
To n, exactly, right? This one.
Yeah,
Perfect.
I was looking for the number that I'm trying to. Yeah.
Perfect. Yep, that's exactly right. So if that's the case, then what do we return?
Yeah. Oh, okay. Then it's
X plus 1. Yeah.
Yeah.
Perfect. And
yeah. Otherwise, you told me to do it like this.
It's fine.
This.
Okay. Cool.
Else, it's x plus 0.
Or just x, right? It's the same thing.
Yeah.
Yep.
I
Perfect.
actually wrote x plus 0. Yeah.
What did there's probably something.
What have I done?
Oh yeah, we need a prime here, right? And I think that fixes everything. Yeah, there we go. Sometimes, okay, so don't get scared. Sometimes you can do a very trivial error, and then you get like 10 lines of red thing, right? So of error. So yes, unfortunately, the errors in Purescript and also in Haskell are not very easy to read. So